Okay, we found out in part 1 how the bounds test actually works. And now we're going to do an example where we see where the bounds test can be useful. Here I have a function f of x equals x to the 6th plus x cubed minus 8x squared minus 4x plus 1. And now we know that this is a 6th degree polynomial, so that we have the potential of having 6 distinct x-intercepts or zeros. Now I've already plugged this function into y1 and graphed it, and this is what the graph looks like. I only see 4 in the picture. The question is, have I found all of the x-intercepts, or if I zoomed out, would I see another one way out here off the graph somewhere? Okay? And I might have to zoom out for a long time before I found it, and I don't know whether I found it or not. The bounds test can tell us if we're looking at all of the zeros or if we need to keep looking. So, and let's zoom in on this a little bit to get a better picture of where these zeros are. I'm just going to go my x window from -5 to 5 and graph that and see what that looks like. This gives us a better picture of the x-intercepts, and it looks like all of the x-intercepts that I can see are between -2 and +2. The question is, are these all of the x-intercepts, or do I need to look for more? Let's do the upper bounds first. We'll check +2 because that's just above the largest x-intercept, and my coefficients are 1, 0, 0, 1, -8, -4, and 1. Okay, and this is x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x, and constant. Drop down, multiply, add, multiply, add, multiply, oops, sorry, this add becomes a 4. Multiply, I get 8. Add, I get 9. Multiply, I get 18. Add, multiply, add, multiply, and add for my remainder of 33. Okay, everything is positive along in here. This is a 4, remember. Everything is positive. Okay, for the upper bounds test, that's what I'm looking for. That means there are no zeros to the right of 2. Okay, now let's do the lower bounds test. -2. And again, I'm going to start with 1, 0, 0, 1, -8, -4, and 1. Drop down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, and add. Now I can see from my lower bounds test that I'm alternating signs all the way across, including the remainder. Positive, negative, positive, negative, positive, negative, positive. And that's exactly what I'm looking for the lower bounds test. This means that there are no zeros to the left of -2, and that this graph shows all of the x-intercepts of this function, all of the real zeros of this function.